Good morning, everybody. I am Ernesto Szarglowski from CAF Development Bank of Latin America and from Universidad Torquato Di Tella. And I am honored today to present Ted Miguel as the keynote speaker of this Albert Hirschman LACEA Lecture. This is, of course, a lecture on development economics, and Ted Miguel is today one of the main contributors to this field. Ted earned his bachelor's degree in both economics and mathematics from MIT, received a PhD in economics from Harvard University, where he was a National Science Foundation Fellow, and has been a visiting professor at Princeton University and Stanford University. He has published over 100 articles and chapters in leading academic journals and collected volumes and 3 books. His work has been cited over 35,000 times, according to Google Scholar. Ted is a faculty research associate of the MBER, is on the board of editors of science, and has served as associate editor of the Quarterly Journal of Economics. Moreover, he's a recipient of the 2005 Alfred Sloan Fellowship and the 2005 Kenneth Arrow Prize in Health Economics, and a 2002 Berkeley Hellman Fellow. Last year, Professor Miguel was elected as a member of the American Academy of Arts and Sciences. Albert Hirschman was not an orthodox thinker. He taught us the importance at the core of economic development of thinking simultaneously about economics and politics, and also about the importance of fieldwork during his years in Colombia. Although, as far as I know, Ted did not fight in 2 wars like Hirschman did, Ted, since 2000, is a professor at the University of California at Berkeley, where Albert Hirschman was a Rockefeller Fellow from 1941 to 1943. In particular, Ted is the Oxfam Professor of Environmental and Resource Economics and Faculty Director of the Center for Effective Global Action at the University of California, Berkeley. Ted is also, like Hirschman, an extremely creative scholar who thinks out of the box, a contributor to the field of political economy, and somebody who knows the importance of conducting work in the field, in his case, in Kenya, Sierra Leone, Tanzania, and India. Ted's main research focus has been on African economic development, but he's also concerned about Latin America. And for those who wonder, Ted's family in Montevideo made him a fan of Nacional, El Bolso. Today, Ted is going to lecture us about targeting impact versus deprivation as a key question for the design of anti-poverty programs. Ted, you have 45 minutes for your lecture, and then we will have 10 minutes for Q&As. For those in the audience who want to ask any questions, please type them in the Q&A box of the Zoom webinar at any time during Ted's presentation, and I will receive them. Ted, thank you very much for your participation at the LACEA LAMES conference in this lecture in the honor of Albert Hirschman. The floor is yours. Thank you very much.
Thanks so much, Ernesto, for the introduction. It's really an honor to be here and to be able to give the Hirschman lecture. I'd also like to thank the organizers, Juan Vargas and others, for really putting on a great conference. As Ernesto mentioned, I'll be presenting on targeting impact versus deprivation, and I was fortunate to work with great co-authors, Johannes Haushofer at Stockholm, Carlos Paramo, who's a PhD student here at Berkeley, Paul Niehaus at UC San Diego, and Michael Walker, who's a postdoc here at Berkeley. We're concerned with the issue of targeting in this paper, and of course, targeting programs is really a core aspect of the design of public policy, in particular for anti-poverty programs. The traditional approach is to attempt to target the benefits to a group that's the most deprived population in some way. It could be the group with the lowest consumption or income or assets, or with the worst nutrition. And over the last few decades, a large literature has developed to really figure out how best to identify these most deprived households, including how to do so at large scale, because government programs that are conducted at national scale need to be able to deploy resources to millions of households in some sort of feasible and cost-effective way. The most widespread approach for doing so is through proxy means tests, PMT, which basically identifies a small number of easily observed characteristics and then targets according to those characteristics. But there's a number of creative approaches that have also been used, community rankings, ordeal mechanisms, and even more recent approaches using new technologies and new types of data. And the kind of development of this whole approach around targeting really emerged, in the 80s and 90s with the rise of poverty measurement in development economics. And there were some famous contributions about how to conceptualize poverty, how to measure poverty. And really as an outgrowth of that was saying, well, now that we know how to measure poverty, now we can identify the poorest, and that's where programs should go. Now, more broadly, what we're going to discuss in this paper is that, if we step back and think about welfare maximization, it's immediate that targeting should depend not just on deprivation, but really the joint distribution of deprivation and also the impact experienced by those who receive a program. And that'll be a starting point for this paper. Really, we're inspired in this study in part by a recent group of papers, and I've cited some of them here in development economics, showing that treatment effects of programs are often highly heterogeneous. And this is true in the microfinance literature. This is true in some of the health literature. There are some households or individuals who benefit a lot and others who benefit much less. And the question that we ask here, given how heterogeneous treatment effects are, is it the case that the deprived are also those who experience the largest treatment effects? Or could it sometimes be the case that the poorest of the poor lack the complementary inputs, they lack the circumstances, they lack the opportunity to make the most out of assistance? And I think here the microfinance literature is really instructive. In some of the recent literature, individuals who already own a business, who are already pretty successful entrepreneurs, are actually those who seem to benefit the most from receiving a loan. Now, they may not be the poorest of the poor. So the question we'll ask is, if there is some sort of trade-off, we're going to first see if there is a trade-off in our data, but if there is, we'll ask the question, well, how much more would a social planner need to value the gains among the deprived to rationalize targeting the poorest of the poor rather than those who experience the greatest impact? So that's the starting point of the paper. There's really a whole nother set of concerns we might be interested in general around political economy. In the real world, programs may be targeted because of the political considerations to maximize the votes of a political party, et cetera. That's not our focus here. We're going to be thinking about the planner, optimizing a social welfare function with the trade-off we have in mind. Of course, real world programs have more complicated rationales and designs. Okay, we're going to focus in particular on cash transfers. And this tension could be quite relevant for cash transfers because of the flexibility of cash. When people receive cash, they can do many different things with them. And in particular, for some people, the cash could lead to high returns if they make investments, and for others, less so. And again, as I mentioned, in the case of microfinance, it's well documented that the returns on investment across households might be very different. There could also be the case that, in the case where preferences are non-homothetic, maybe richer households and poor households spend on different things, and the social planner could care about that. They may value particular types of spending more than others. There could also be some sort of divergence between the preferences of households and the planner for instance, if the planner discounts the future less than certain households, they may value investments that lead to higher future income, more than current spending. So, for a variety of reasons, the planner may care a lot about how this cash is used. In a world of pervasive market failures, which we think would be quite typical in low and middle income countries with credit constraints, et cetera, certain households that experience severe credit constraints, may benefit differentially from cash than those who don't. There could also be psychological factors and biases that affect the impact that cash has on households. So these are the sorts of issues we're going to try to study today, focusing on this empirical question. Is there even a trade-off, though, between targeting the poorest and generating the largest impact? That's going to be the first part of the talk. In the second part of the talk, we'll put those results in a social welfare function and try to figure out the implications. All right, so that's the kind of roadmap of what we're doing and where we're starting. We're going to study cash transfers in an African setting where I do most of my work. But I think a lot of the issues we're discussing will be relevant for other countries, other low and middle income countries, and for many Latin American countries where cash transfer programs are very widespread. And some of these same issues of trade-offs could still apply. In particular, in this Kenyan settings, households that are eligible for the cash transfer, and eligibility in this program we study was based on a simple proxy means test, a certain asset that the household owned. They received a large lump sum unconditional cash transfer. It was actually a very large share of annual income. And the way the program was designed, a very large share of households received the cash, 35 to 40% of households. So this has quite broad coverage in rural Kenya. And I'll talk about the implications of that later on. Methodologically, one of the things that we really spent a lot of time on, and I think most of our effort in the project over the last year, was spent learning and applying the latest machine learning methods so that we could predict deprivation and impact using the best possible tools that are available today. And I think by this point, people are quite familiar with the benefits of machine learning relative to some of our traditional regression approaches. Machine learning methods help us deal with overfitting, so they're more regularized, and as such, they do a better job of predicting. And I'll discuss that below. So we use these methods and rich data to predict deprivation and also to predict conditional average treatment effects for households. And we focus on impacts of this cash transfer program on 4 very common outcomes that policymakers care about: consumption expenditures, income, asset ownership, and food security. So these are the sorts of outcomes that a lot of policymakers or planners would look at as key welfare metrics or living standards metrics. And that's going to be our focus. Let me also say something that's a little different about our approach is this whole approach of using machine learning, of focusing on these 4 outcomes, and the specific covariates we use in prediction was all pre-specified. So we wrote a pre-analysis plan back in 2017 when the data collection was still going on to lay out this approach, and then we follow this pre-analysis plan here. So one of the things I'd like to emphasize is this is a novel application of pre-specifying a machine learning approach, because even with machine learning, there is some scope for data mining and other things, data mining in the way we would find inappropriate. Okay, finally, last point to emphasize about the setup, what we're going to be doing when we think about targeting, really for simplicity and statistical power, is we're going to be imagining a program going forward where we could target transfers to half of the population that we study. So that's the budget constraint we'll propose, and we'll say, well, if we have funding to target transfers to half the population, who should receive those transfers? Which 50% of the population? Should it be the 50% of the poorest? Should it be the 50% that receive the largest impact? Or when we generalize to look at a social welfare function, there's going to be a potentially separate 50% of households that lead to the largest gains in social welfare. So that's really the idea. There are going to be these three groups that we'll talk about. Great. Okay, so that's the introduction, and I think already maybe gives you a flavor for where we're going here. Let me step back and give a little discussion on the conceptual framework, and then we'll get into the machine learning methods and the results. So just to step back and think about the problem we're dealing with, we actually have a very general setup, and this is a setup that's common in public economics, that's common in the empirical welfare maximization literature in econometrics. Imagine we have a planner, and they're trying to figure out which households or individuals I should receive a treatment. And the treatment status for individual I is T sub I, so either you get the treatment or not. And the planner cares about maximizing the social welfare function, W, which is summed up across individuals in this population. So this is a kind of utilitarian style approach. We're adding up utility across individuals as a function of their outcome Y, where of course Y can be affected by treatment. Again, imagine consumption or income. Receiving the treatment could affect those outcomes. And again, we'll have a standard social welfare function that's increasing in Y, but with some weak concavity. What we can do immediately here, and this really sets up the whole rest of the paper, I think, is think about Y sub I in potential outcomes notation, which we're all so familiar with now in the experimental and program evaluation literature. Y sub I for me is my Y naught. Y naught is my outcome absent treatment plus the effect of treatment on my outcome. And the effect for me individually is delta sub I. So I kind of receive that gain from treatment if I'm treated. If not, my outcome is Y sub I. So again, this is just standard, standard notation. But when you view it this way, you can immediately see the tension for the social planner. If we have a concave social welfare function, the planner would tend to want to target the worst off, because let's say delta is the same for all households. Well, then the marginal utility gain or the marginal gain in social welfare is largest for the poorest households. They start with the lowest Y naught. That delta means more to them. At the same time, there could be a trade-off, because it could be the case that those who experience the largest delta are not those with the lowest Y naught. And in general, the joint distribution of Y naught and delta is going to matter, as will the degree of curvature in W. So this is the issue that we're concerned with. Now, in terms of operationalizing this, in practice, there's a lot of challenges, and these are some of the challenges that are well known in the existing targeting literature. First of all, if we want to understand these potential outcomes or treatment effects, it could be challenging. There's the issue of counterfactuality, meaning we can only observe either Y1 or Y naught for an individual household. So we don't know, exactly what their treatment effect was. We only observe them in one state. There could be issues of verifiability. So even collecting data that's needed, there could be misreporting from households, and it could just be costly to measure all the data that we need to do this exercise. So there's a lot of challenges. What has typically been done in the population is the planner observes some relatively easy to observe covariates X. So imagine the vector X sub I in the population. And then we're also in a position in our study, and some other recent work does the same, to link those X's to the outcomes in an experimental subsample. So, imagine we actually can observe Y of T in the experimental subsample, and that's going to allow us to estimate treatment effects. So this is our setup. Typically in the field, and when governments are designing programs like this, the X vector are things that are easy to observe, major assets the household owns, maybe basic demographic structure, broad employment sector, meaning is this a rural farm household, an industrial worker, et cetera. And in our exercise, we're going to mimic that process. We pre-specified 16 outcomes that look like these typical proxy means test type covariates. Finally, once the planner observes the X's, the Y of T, they want to assign a decision rule figuring out how do your X's map into your treatment. And this is where, for us, the machine learning is going to come in, or any sort of prediction is necessary here, subject to budget constraints and whatnot. All right, so to start, let's assume we have these predictions. I'll say more in a few slides about how we obtain them. So imagine we actually can create predictions of Y naught and delta, meaning how poor, how poor you would be, say, in the absence of treatment, Y naught, and what your treatment effect would be, delta, given your covariate vector X sub I. Suppose we can obtain that from the experimental data, then, in practice for policymakers, the norm has been to target based on those predictions. So for instance, if the plan was to target the poorest of the poor, if that Y hat, the predicted Y naught was below some threshold, you would receive the program. If it's above the threshold, you don't receive the program. That sort of rule is used in dozens of countries around the world. We're going to go beyond that to consider both of these, Y naught and delta. And let me just say one thing. What we're doing is closely related to the empirical welfare maximization literature in econometrics, pioneered by Mansky. There are really, beautiful recent contributions. Kitagawa and Tetanov, Athey and Vager, Viktor Chernozukov and co-authors have several papers along these lines, and we build on them, and we use a lot of their tools. So our paper here is not an econometrics paper. We're not deriving new asymptotic results here, but what we are doing is applying these tools and making explicit a trade-off that's actually very important for policymakers that really hasn't been a focus of that literature so far. So that's our contribution if you want to see where we fit into this, this literature. All right, okay, I mentioned before there are going to be 3 different targeting rules. Let me briefly mention them. I've alluded to them. The first targeting rule is the classic approach of saying we're going to focus treatment on the most deprived, on the poorest. So here you can see the decision rule is you receive treatment T if your predicted Y naught is below some threshold. Here, that's the Q sub alpha, where again, the alpha may capture, the share of population that can be treated. A second rule is to target the most impacted. The other extreme would be to say, well, we have these estimates of delta hat, who benefits the most. If all we care about is the most impacted, we're going to target it to those who benefit the most. So for delta hat above a threshold, we're going to target those households. For instance, if the planner imagine the outcome that the planner cares about is income, and they just want to maximize the income benefit of the program or the income gains, they would focus on the most impacted. Third is the balanced approach, which incorporates the social welfare function, as you can see in the expression there at the bottom. What the expression there is saying is the households that are going to be targeted are those who, when targeted with the program, generate the largest gains in W, in the social welfare function. And again, this is going to depend on the joint distribution of Y naught hat and delta hat and curvature. If there's a linear social welfare function, they're not really going to care about the deprived. They're only going to care about the most impacted. If there's a very curved social welfare function, effectively, they're only going to care about the most deprived. For anything in between, there's going to potentially be this trade-off. All right, so that's the setup of what we're doing. Let me tell you a little bit more about the machine learning and the other methods, and then we're going to get into the results. So the setting that we're in is in rural Western Kenya. You can see the study area in green. We worked in a pretty large sample, 653 villages with a total population in this area of about 300,000 people. We actually censused all the households and businesses in this area for a first paper that came out of this project that I'll mention in a second. The villages are pretty typical for rural Kenya. There's about 100 households per village with 4 or 5 members, a large share of children. Survey respondents have some education, but not a lot. The younger generations in Kenya have much more schooling than this. And as you'd expect in a rural area in East Africa, almost everybody is engaged in agriculture. Almost everybody has a plot of land that they're working in. But there's a variety of other activities they're engaged in as well. Small businesses, wage work, sometimes seasonal. And that makes for a pretty complex situation when you're measuring living standards here. But we carried out very detailed living standards measurement survey type surveys to capture the richness of the setting. The other thing I want to mention is the period where we have data, 2014 to 2017, is notable because it was a period of steady economic growth. There were no national elections during the data collection period. It was basically a very stable period where Kenya was experiencing 4 or 5% growth. So, think of this as a time without major disruptions. This is before COVID, et cetera. The program that we study was implemented by Give Directly, a large NGO that distributes unconditional cash transfers. Again, they aim to enroll the poorest households, and the proxy means test for them is having a grass thatched roof, meaning having a kind of grass roof rather than a metal roof. And it's a kind of rough but very cheap to collect proxy. And those are the households that are eligible for the program. Because it's only a rough proxy, one of the things that we'll talk about is actually, if you look at the distribution of income or consumption or asset ownership in this population, the eligible households, yes, they're a bit poorer than the ineligible households, but there's a tremendous amount of overlap in the distributions. So the households in the eligible population are actually fairly representative of this part of rural Kenya, just a little bit poorer. The fact that 35 to 40% of the population was targeted also sets the program apart from existing programs in Kenya. There are some public cash assistance programs targeted to widows and orphans, things like that in Kenya, but they really only reach a very small share of the population in this county. So again, the program we study is sort of much broader. The money was distributed to households through mobile money, the M-Pesa system, over 8 months, and they're very large transfers. So it's $1,000 in nominal terms, or closer to $2,000 in PPP, and that's about 75% of average annual household expenditure as we measure it. So this was really a huge income shock for these households. Okay, the kind of design of the program had a two-stage RCT design. We were very interested in the initial paper that came out of this project in studying spillovers, in studying the broader effects on the local economy of cash. It's a very large project across these 600 villages, and there was randomization not just of villages into treatment, but also little subregions called sublocations that were either saturated with cash or not. Again, we carried out very detailed data collection. We censused all households and businesses, carried out detailed baseline and endline surveys that are really the source of the data here. Our focus today is going to be on these eligible households, the ones who received cash, because it's in that population that we can measure treatment effects. So that's going to be our focus. But as I said, since the eligible and ineligible are fairly similar in covariates, there could be some broader implications for impacts in this region. Again, as I mentioned, we collected covariates that are commonly collected in similar studies. And so overall, we have about 5,000 households surveyed at baseline and endline. We have very good survey follow-up rates and balance. Let me mention one other thing that's important. The endline survey was rolled out over time after the cash was distributed, and the data was collected between 9 months after receiving cash to 31 months after receiving cash. So, roughly a year to, or, a little less than a year to 2.5 years after receiving cash. So we're actually going to be able to measure effects with a little bit of a lag. You could think of the impacts that we measure as something like maybe the medium run effects of receiving this program on household outcomes. So quite important for policymakers who are interested in seeing if there are some persistent gains or benefits from the program. What we are missing, just due to the way the data collection was designed, is the impacts in the first few months after cash was distributed. So I'll talk about the implications of that. There could be some different spending patterns in those early months that could be important for the conclusions. All right, so that's the kind of starting point. We pre-specified these outcomes of interest to policymakers, as I mentioned: consumption, income, assets, and food security. The way we define outcomes is at the household level. So regardless of the number of members of the household, whether it was 1 or 10, they all received the $1,000 in a cash transfer. So obviously, in per capita terms, for the small households, that was a much larger transfer per capita than for the bigger households. So, the way we deal with that is we look at outcomes at the household level. $1,000 went into the household, regardless of size. We're going to measure, say, gains in consumption overall in the household. So it's sort of dollar in and dollar in output, and that helps us correctly estimate impacts, relative to looking at per capita, which would sort of, have these mechanically larger gains for the smaller households. One last outcome that we won't talk about as much is food security. the way we measured food security wasn't through sort of measuring this financial outcome, like just measuring income. We asked a series of questions about whether the household hadn't eaten meals in the last week and those sorts of things, which is pretty common in this literature. But those are a bit harder to interpret. So, meals per person is already in a per capita kind of, by design, it's kind of a per capita measure. So I'll mention the food security results at the end, but they're a little harder to interpret than our main 3 outcomes. All right, maybe that'll be clear when I get to it. It's probably a little hard to follow the way I'm describing it. All right, 1-minute summary of the first paper that came out of this project. This is the Egger et al. 2021, which is now actually forthcoming in Econometrica. The impacts that of the main program were quite substantial. Cash went into these households. We show impacts among households that received the cash in the outcomes considered here, and many others. One thing that's noteworthy in the first paper is we did attempt to estimate treatment effect heterogeneity using kind of standard tests, interactions with a few covariates. We don't find much evidence of heterogeneous treatment effects in the first paper, although we're somewhat underpowered. But that, lack of power really, motivates us to use, more modern tools, machine learning tools like we do here today. The central finding and the sort of most novel finding of the first paper is we found large spillover effects onto untreated households in this area. So, the non-recipient households also show consumption gains. We show that local businesses show revenue gains when cash comes in. So we're able to trace out what happens to the cash transfer and how it moves around in the local economy. We're also able to compute a multiplier, like a macro multiplier that's greater than 2. So quite a substantial multiplier effect of cash in this setting. Now, one of the issues, that's a result we're excited about. It does pose some complications for the targeting analysis here, as I'll talk about. If we make certain assumptions, if we assume that the spillovers sort of are caused and experienced by all households in the same way, then it won't affect the targeting analysis here that we'll talk about, because those spillovers will just be additive to what we're doing. There are certain cases, though, in which certain subgroups would gain most from the spillovers that could complicate our analysis. And I'll mention below what we've done. What we're basically able to do is, using the same machine learning tools we'll talk about here, estimate the relationship between deprivation and experiencing spillovers. So I'll come back to that later on, but that's a methodological issue that we have to deal with given our design. All right, let me get to the machine learning for 5 minutes, and then we'll get into the results. The algorithm here is very standard for machine learning tools. We have a data set. We split the data into folds. We use 5 folds, although the results are robust to 2 folds, 5 folds, 10 folds. And what splitting into folds allows us to do is to have training data, a subset that's used for estimation, and then data where we apply those estimates. So what this means is my own observation, so the link between, say, y and x, for me, never affects what the predictions that are assigned to me. Those things are separate because the estimates are done among the training data, and then they're assigned to the left out fold. And again, this is a kind of typical approach in machine learning. We do this to both estimate the y naughts and the deltas, and we do it across many of these splits. So we actually found that after having about 100 iterations, the data stabilizes. So all of our estimates are based on 150 different data splits into these K folds. And by doing this, we're able to assign households to the most deprived half of the sample and the most impacted half of the sample. So again, that's going to be our goal from this training exercise. Now, in terms of what we do in particular, we're really inspired by a lot of the work of Susan Athey and co-authors. We use some of their recent generalized random forest methods. Random forests are actually very good methods to use to study, nonlinearities and interactions, possibly complex interactions between covariates because of the way the splitting works in the trees. The sorts of covariates or features that we use were these pre-specified ones. that I mentioned. And again, we do this over 150 different k-fold splits. Again, to get out of sample accuracy and prevent overfitting, generalized random forests use what are called honest trees. That means within each tree, the splitting within the tree, again, is not based on my own observation. There's sort of some observations used for splitting, and then those splits are used for the remainder of the sample. So again, all of this is done to try to control for overfitting. We also use a more conservative set of parameter estimates that Athey and co-authors suggest to make sure that we're not overfitting. So we do everything to be sort of cautious to deal with overfitting here. And what this yields for us, once we're able to generate these predictions, is a set of predicted effects and also actual averages. So once we've generated the Y naughts and the deltas, we can come up with, you know, the average Y naught for a particular group, say for the most deprived, the D group, or the most impacted, the I group. We can also come up with a predicted delta, a predicted treatment effect, given this estimation. What's very nice for us with the experimental subsample is we also have the actual averages for both of these. So for the control group that never received treatment, we observe their Y naught directly. We know what their outcome is in the absence of treatment. So we can compare the predicted Y naught to the actual Y naught to sort of validate this machine learning method. Similarly, we know what the average treatment effect is in this population because we have an experimental design. So we have an estimate of delta that we can compare to the predicted delta. So that's, you know, really a nice thing here, and I'll show you some of these comparisons. In terms of inference, we follow Chernozhukov et al., and we conduct inference conditional on assignment to these different categories. And then we also have a kind of more conservative randomization inference approach following Ding et al. To get appropriate p-values. So again, there's a lot of cool new econometrics here that I think for those of us who are applied people, we learned a lot in the last couple of years here, and you know, we really understand the value of these tools now. Okay, so let me get to some results, and I'll just start by conceptualizing the findings. This is simulated data, this figure here on slide 20. So this is a plot where the x-axis is predicted Y naught, predicted end line, let's say consumption. As you move to the right, the households get richer. The y-axis is the predicted treatment effect, the predicted delta. This is how much you gain. So this is a simulated example with made-up data where the poorest households, the ones on the left here, gain the most. You target the poorest, they benefit the most in terms of consumption or income. Here, there's no trade-off. We would definitely want to target the most deprived. They're the most deprived, they see the greatest impact. There's no trade-off here. Okay, that's case one. So remember this downward sloping relationship, no trade-off. Case two is different. Case two says now the people on the left, the poorest, on average experience a smaller impact. And it's some of these better off households. Maybe they're richer, maybe they have other assets, maybe they have more education. They're the ones who are benefiting the most in terms of delta. Here there's a trade-off, and when we're thinking about which group to target, you know, the curvature of the utility function could be quite important. Then we have the third case here, case C, where maybe there's no clear relationship. You know, there's some households that gain, it's not that closely linked to deprivation. There could be, you know, not a clear kind of upward or downward sloping relationship. All right, this is the simulated data. So now what I want to do is show you right away the plot that corresponds to this. X-axis is Y naught hat, Y-axis is delta hat for our three main financial outcomes. Okay, so this is real data now. And let's start with consumption, the plot on the left. What you can see here is we have our predicted end-line consumption for the household. It ranges from about $1,000 to $3,000 per household. And again, this is the, you know, the prediction. And then we have the predicted impact of getting this cash transfer on your consumption 9 to 31 months later on. And you can see very clearly here that this is upward sloping. So in this, you know, very important measure of living standards, consumption, it immediately comes out of the figure that there is a trade-off in our data. The better off households have sustained higher consumption a couple years later. The poor households, not by much here. And the difference in the treatment effect is pretty large. It goes from, you know, 200 for the poorest households to over 300 something for these households with higher consumption. All right, so this is an important first finding. we have these colors here just to easily show you the different groups. The yellow here are below median in deprivation, above median in treatment. That yellow is the group we like. They're poor and they gain a lot. There's another group which is just deprived. The blue and the green is just high impact, but not deprived. And then there's this red group that's richer, and don't experience much impact. So again, these are the different groups that we can classify households. It's also noteworthy that there's a lot of variability. So really throughout the range of deprivation, there's some households that happen to gain a lot. When we turn to the other two outcomes, income and assets, the relationship is a little less clear. It actually turns out the slope is weakly positive, especially for assets. It's actually, you can kind of see the upward sloping relationship with assets, but it's a little bit flatter for these outcomes. And again, you can see there's households in all of these colors, but really only a subset of the households are in the yellow. So it's not obvious that there's like a clear group that would get targeted if we only targeted on deprivation or impact. All right, so this is a kind of first set of main results. What I want to do next is show you the correlation between the impacts in these different groups, just to show you that they're pretty highly correlated. It turns out that if we correlate gains in consumption with gains in income, or gains in consumption with gains in assets, you can see those correlations here in this matrix, and then we plot out the data in the bottom left. You can see the same sorts of households that are gaining in one of these tend to be gaining in all of them. And there's a couple of explanations for this, but the most obvious one is there's some subset of households that get the cash and then generate some sort of flow of income even 1 or 2 years later that allows them to keep consuming more, keep accumulating more assets. If it was just a question of, okay, there's high marginal propensity to consume households and low marginal propensity to consume households, and that's all there was, you might expect some negative relationships between these variables. So I'm either accumulating assets or I'm consuming, but the fact that all of these are positive suggests that really there's something about the return on investment that matters. I also want to emphasize here is we are observing these households, again, 9 to 31 months later. We are missing any burst of initial consumption. Maybe the poorest households consumed a lot in the first few months. We're not capturing that well in our data. Okay, so we're looking more at the medium run effects of the program. Okay, let me go through and sort of finish some of the machine learning and then get to welfare. And I think I have maybe 5 or 6 minutes left, Ernesto. You can, okay, great. So this is a table of the machine learning predictions and the actuals. So let's mainly focus on panel A. I may not have time to go through every number here. Focus on column 1 in panel A. These are our consumption predictions from the machine learning and the actual. The first thing that you'll see is the predicted consumption at end line. This is the control group, is about $2,500, and the actual is $2,500. So this is actually pretty striking. The machine learning did very well in not overfitting. The prediction and the actual are very close. When we go to the most deprived group, those predicted to be poorest, it fits well. Same thing for most impacted. So, it is nice that the machine learning is doing quite well in this data with the amount that we've done the regularization. The other thing that's noteworthy here is, well, column 2 is not surprising. The most deprived have lower consumption than average. So column 2 is less than column 1. That's not a surprise. But as we showed you before, the most impacted group has considerably higher consumption than average. The most impacted are not the poorest of the poor. They're, on average, $600 richer than the poorest. So that is, highlighting the trade-off we talked about. Now, if you go to panels B and C, you also see, these gaps in income and assets between the most impacted and most deprived, suggesting there's a trade-off, although it's not quite as large. But again, that negative value in number 4, that's quite, the larger that value, the more the trade-off between targeting the most deprived and the most impacted. Very quickly, we do something similar in predicting treatment effects. If you look at column 1 again for consumption, you can see the prediction and the actual are quite close. So again, the machine learning tools did quite well. The average treatment effect for the most deprived is lower than average. The average treatment effect for the most impacted is considerably larger. The randomization inference p-values on the right are basically a test. Can we reject equal treatment effects? And you can see by those low p-values that we can reject homogeneous treatment effects. There really are different treatment effects across these groups. But for panels B and C, the p-values are weaker. There's not as decisive evidence of heterogeneity in terms of income and assets as there is for consumption later on. All right? So that's kind of tying up the kind of main data on the trade-offs. Let me just very quickly talk about the economics of the machine learning. What are the features or covariates that are very predictive? One of the striking findings for us was that the larger the household is, the more it tends to gain in terms of predicted treatment effects. And you can see that in columns 6 through 9. The bold numbers there, and the number 1 means this was the most influential covariate. And this is not mechanical, because the same size transfer went into small and large households, and then we measured the financial outcomes in the same units. There's something about larger households that lets them translate the transfers into better economic outcomes. In terms of other variables that help households sort of do well with the cash, you can see this more in the bottom panel, households that had more assets at baseline, households that were employed at baseline. Basically, households that were more entrepreneurial or a bit richer tended to do more with the cash. The flip side is, if you look at that row that says widow, the N line, under N line predictions, a household that has a widow, being a widow is one of the strongest predictions of being poor at N line. So again, it just really highlights that if we were to target on impact, we'd be targeting some of these better off households. If we were targeting on deprivation, we'd be assisting households like widows. All right, so there is, in the trade-off here, there really are important differences between these households. Okay, so let me show you the welfare analysis and then we'll conclude. Welfare is a hard thing to conceptualize. You know, Amartya Sen taught us maybe it's not just outcomes that matter, it's opportunities or capabilities, other things that matter. We're going to be a bit more conservative here and narrow and focus on a classic CRRA utility function with, you know, curvature as our social welfare function. We're going to add up outcomes across households in this very standard framework. Of course, in CRRA, if rho equals 0, it's linear. I don't care about deprivation, just impact. And the higher is rho, the more curvature there is. Now, what is the right rho? That's debated. When subjects in Kenya have been surveyed, they typically have rhos between 0.5 to 1, so kind of roughly log utility. Here, we're going to consider values between 0 and 4. So 4 is a lot of curvature. Just to give you a sense, if rho equals 4, then I, as the social planner, if I look at someone with twice the income, I value their utility at 1/16. So pretty sharp curvature here. So what are the results here? Again, let's just focus on panel A, and then I'm going to wrap up. For consumption, when rho equals 0, that top row of rho, all the households that they choose to target, the social welfare maximizing households, are the most impacted. You can see that in column 2. With linearity, they don't care about deprivation. That makes sense. There's still quite a bit of overlap, though, between these groups. Some of those most impacted households, 0.32, were also the more deprived. As rho gets larger, as you go down the rows, fewer and fewer of the most impacted are optimal to target, and more of the most deprived. That said, given the trade-off we identified, rho would have to be above 6 to target the most deprived over the most impacted. And this is a kind of central finding of the paper. There's enough of a trade-off in our data that unless the planner has highly redistributive preferences, they wouldn't choose to only target the most deprived, which is the way current policy is carried out. All right, so let me skip over food security. People can ask if there are questions about it, and I'll just talk about extensions for 10 seconds and then the conclusion slide. So we're still working on the issue of spillovers. So far in preliminary analysis, we're not finding very strong relationships in the spillovers that mirror our main findings. So we're not as concerned that our findings are really being driven by spillover, but we're still working on this. We're very interested in dynamics. As I mentioned, we're only studying effects 9 to 31 months later. It would be interesting to understand the first few months of consumption. We compared our machine learning methods to OLS. OLS leads to a lot of overfitting in our data. You would have quite different results because OLS leads to overfitting. Okay, so let me just conclude. We lay out a framework that highlights a trade-off that hasn't been a focus of work so far, and we do find that this trade-off exists. In our data in Kenya, those who experience the largest impact of a cash transfer program very often are not the most deprived. And that could lead to a trade-off for policymakers. That said, it'll depend on the curvature of the social welfare function. It may depend on the outcome of interest. So, more work needs to be done. Very important, and I'll stop with the last point on top. Our study area, the results may or may not generalize to other areas. This is an area, as I mentioned, of where the gaps in income between the relatively rich and poor are not that large. The richest households are maybe 2 or 3 times richer than the poorest households in this part of rural Kenya. I think this is critical, especially bringing it back to Latin American development, a very high inequality region where the poorest may have much lower income than the richest. The trade-offs would be much sharper in an area with higher inequality, and that may push for more targeting of the deprived. Let me leave it there, and thank you.
I have some questions for you. One is from Felipe Barrera Osorio. Mm-hmm. He asked, why do you focus on these 4 outcomes: consumption, income, assets, and food security, and not also on education and health, which are typically 2 variables highly impacted by cash transfer programs, and variables which could also show high heterogeneity in results?
Thanks a lot. I mean, that's a great question, and I personally care a lot about health and education. A lot of my work is in that space, so I'm very sympathetic to the question. We focused on what we were trying to use as like summary measures: consumption, income, and wealth as summary measures of well-being. And the thinking is, once you have more of these outcomes, you could purchase more health, education, and many other outcomes. So I think that was our rationale. We also, in the pre-specification, wanted to keep the list kind of narrow. We can do that, though, and I think Felipe raises a good point. The machinery is there. We can look at some of the same, use the same machinery to look at heterogeneity. So thank you for that point. And I've taken a note of that to kind of add that to the analysis going forward. So thanks, Felipe.
Then I have a couple of questions from Juan Vargas. Juan mentions that Balboni and co-authors suggest that to measure equilibrium consumption, you have to wait long periods in an experiment in Pakistan. And so he wonders whether by measuring consumption after 8 months, you are capturing the transition period or already the steady state. And he also asked if we think that transfers can help people to escape poverty traps, whether that could be an explanation for why if these transfers are not large enough to push households beyond a threshold, then you don't find that the poorest are the most impacted.
Yeah, I think that's a great question. In terms of where we're at, I would think of these as medium run. We're actually in the field right now collecting the long run 5 or 6 year effects. So I think in the future, to Juan's point, we could be looking at long run effects for the same households. And I think that'll be super interesting to try to understand, like, were there really persistent effects for some households 5 or 6 years later or not? That's our kind of next step. We are missing these first few months. I think the ideal, if we were, write down the social welfare function, would be to say we want the discounted, value of future consumption or future income. So we have a slice from 9 to 31 months. We're kind of missing the first few months. We're still going to get the longer run. But I think it's right that all these periods could matter for welfare. I really like the point you raised about sort of pushing people out of poverty traps. And it's something we've thought about is, what we've learned in development the last decade is some of these programs that have been successful at breaking poverty traps are these like targeting the ultra poor programs. They're really multifaceted programs. There's cash, there's asset transfers, there's training, there's social support. And all those things together have been shown to kind of help the poorest of the poor have sustained gains. What it looks like in our case is, even though the cash transfer was very large, as Juan mentioned, these households a few years later really aren't getting out of the poverty trap as much as some richer households. So I think it's a really good point and something we hope to investigate with the long run data. So thank you.
There is a related question, Ted, to this issue of a push that the household could need to get out from a poverty trap, about the fact that you are using here uniform transfers, and whether there should be also a policy discussion about targeting the differential transfers and not making them uniform.
Yeah, exactly here. I think on some level for the research here, it was useful to have the one transfer, then we can compare apples to apples. But again, if there really is some sort of nonlinear impact as the size of transfer, the optimal thing would not be a uniform transfer. It almost has to be the case. So I guess our data could feed into that discussion, but I'd have to think more about how. But I think that's right. We have a simple design, useful for the first step, but for policy design, we might want to go beyond that for optimal targeting. Yeah, I agree.
The previous one was a question from Omer Osak. I have a question from myself. You talk about the spillovers, and I was thinking that perhaps one mechanism of spillovers is that if among these households there are some transactions, for example, credit, then a household with a higher potential impact, a household who knows they could have a higher potential income, they can attract resources from the other household, from the household with a lower impact. So it's that, I was wondering if these spillovers will go in a particular direction in this trade-off, which could also may require a particular design of these anti-poverty programs.
Yeah, it's a good question. In the first paper, we looked a lot at that to try to understand the nature of the spillovers. We measured transfers between households in a very detailed way. We measured credit because we were thinking exactly as you thought, Ernesto, that some of the recipients would start lending the money and transferring. And one of the things that we were disappointed by there is there was very little of that interaction, much less than we thought. And it felt like, in the data, what we find is a lot of the spillovers went through local enterprises. So in other words, the local businesses had big increases in revenue when cash went into an area. And then in those enterprises, the wage bill went up and wages went up. So we traced it out more through this sort of enterprise activity channel. That's where there was more evidence of the spillovers and less of this informal transactions, credit, and transfers. But we measured all that because we thought that was a very plausible channel. It just wasn't as key in this setting that we measured. I still think your point applies that different types of people could benefit differentially from the spillovers. The people who own enterprises, for instance, could benefit more. But as I mentioned in our analysis here, we're not finding with the machine learning methods patterns of heterogeneity that mirror our main findings. So we're still investigating the heterogeneity and the spillovers more.
I think we are running out of time. There are some questions I will not be able to make. There is one from Juan Camilo Cárdenas on whether what is your take on incorporating risk aversion estimations on this? On your estimates.
Yeah, so I mean that's a great question. The estimates I cited from the Busara lab in Kenya are experimental real stakes estimates that are being used. There is some other work showing that, and you guys may be familiar with this, that survey estimates and the lab measures are quite highly correlated. So it may not be so sensitive to those estimates, but the ones from Kenya we cite are lab-based, real stakes methods rather than hypotheticals. And, you know, so that's where that range came from in Kenya. Personally, in Kenya, I've done both, and I've tried to validate lab risk aversion measures with surveys, and I've kind of replicated with co-authors, Bauer and Katilova, we replicate some of the other work in sort of European, US settings, showing the surveys actually do a pretty good job of mirroring the lab measures.
I'm trying to use an additional minute for one more question. There is one question also from Santiago Saavedra on whether you try the geographical cross validation between the eastern and western villages in Kenya. And then one more, and this is the last one, from Matilde Machado, asking whether if larger households are the ones with a higher number of children that could justify the larger impact on those households.
Great questions. The geographic cross-validation is a great suggestion. We haven't done that. We could, so thanks for that suggestion. That could tell us something about how results may travel. So thank you, great point. We haven't done that yet. On the point of the larger households, certainly the larger households have more kids, and often kids with a range of ages. And so as we think about why the larger households gain more, you know, think about, you know, a setting with not the best input markets, not the best labor markets, not the best credit markets. Having more household members could overcome some of those frictions, for instance, to start a business or an income generating activity. So, you know, that could be part of the story, and maybe adolescent kids are part of that story in terms of contributing labor to the enterprise. So yeah, that's kind of along the lines of how we're thinking about household size might matter.
Thank you very much, Ted. As I was mentioning at the beginning, Albert Hirschman was a multidisciplinary mind, and you also think broadly. But I like your stress in highlighting and studying the trade-off. That is something particular of economists, and in many cases in Latin America, we economists we feel alone because people don't like trade-off. People like that I don't know, more expenditure but not paying higher taxes. So we are quite unpopular in Latin America because we are the only ones mentioning a trade-off. So having you studying in such a detail a trade-off is extremely valuable for us. So thank you very much again, Ted, for joining this LACEA Lamens conference with your work.
Gracias, Ernesto.
Muchas gracias.